Okay, so I think somebody raised up his hand earlier or has dropped his hand. Yeah, so the individual has dropped his hand. Okay, Mr. John Atipoju. All right, Mr. John. Mr. John, you can unmute yourself. Mr. John, can you speak up, please?
Hello, sir. Here, can you hear me?
Yes, please.
Okay. Sorry, sir. I just want to solicit on behalf of my colleague who can't join the class presently. We just finished the class. It was around past 3. Few minutes past 3, I finished the class, and before they could actually join, it was already late. So I just want to plead on their behalf if you could allow them to join, sir. Because of course, I also had to join immediately the last class ended, which was around past 3, right? So I don't know, sir. I just want to solicit your indulgence, sir, please, sir. If you could allow them to join. Thank you, sir. Yeah.
Yes, I've heard your point. All right, so as I was saying earlier, I said once you go for a party or to go to a restaurant, there's an individual who comes to you, right, to ask you what you need, what you want, what you care for, right? So that person is usually called a server or a waiter. So let's use the party example to illustrate our concept because it will serve a lot of purpose or purposes during this period of this lecture. So you have let's assume you have a corner where you have, let's say it's a marriage. So you have two families coming together. So one family will cook, put his caterer by one corner, maybe the family of the wife. Then the family of the husband, we also have a kind of stand, right? They will put their food and other things there. So they will now deploy servers to come and ask you what you need. Now, let's assume that the family of the wife, that's a tentative assumption, the family of the wife prepared pounded yam. Then the family of the husband prepared jollof rice. Now, in addition, the family of the wife, in conjunction with cooking pounded yam, they added some good drinks, like let's say malts, some different, what's the name? Drinks, assorted drinks, right? The family of the husband to have different kind of drinks. So they have trays that they can use to serve you. So the waiter comes, say, good afternoon, sir. What do you want? So you write down what you want, goes back to the stand and asks them to serve you what you want, then brings it. So what they do is that they put a collection of stuff, like they put pounded yam, they put a goosey or whatever soup you want, they put 2 pieces of meat, 1 fish, they put a lot of assorted stuffs here and there, right? So all these things are brought back to you in a form of package. Then they now bring drinks. So everything placed in front of you is for you to devour. If you are from the husband side, you have the opportunity to eat probably rice. So they'll put rice, they'll put meat, they'll put some other things that will just make your life comfortable, kind of, during the meeting or during the program, as it were. So in all this, the whole concept is that you have the opportunity of choosing what you want as maybe as feeding. You could also tell the server that, okay, can those people sitting on this table, So they came with the wife. Can they have rice instead of just pounded yam? So we're going to be looking at these concepts in that light. We look at servers, we look at cloud computing, we look at deployment, we look at development. I'll be using some of these scenarios, or be creating scenarios and using it to explain some of these things. Yeah, for those of them who wish to join, they have the period of 10 minutes to join. All right. So what is cloud-based, or what the concept of cloud-based software? So let's talk about the cloud. Now, we listened to one House of Rep member telling us that how do you now get the information you store to the cloud? Is it going to fall down like rain or what? So let's start by telling ourselves what the cloud really is, or what the cloud system really is. So the cloud is made up of a very large number of remote servers. I'm sure you know what servers are. Just as I give example, somebody who comes to ask you, what are your needs, right? What do you want? Then he goes to the repository, or where the food is domiciled. He picks a few things that you need and brings it to you. So the cloud is made up of large numbers of remote servers that are offered for rent by companies that owns this server. So the cloud-based servers are virtual servers. So when you say something is virtual, that means they are implemented in software rather than the hardware you are used to. So you can rent as many servers as you need. Run your software on these servers and make them available to your customers. So cloud systems are just several number of servers remotely that they are stored there. So when you say something is remotely, that means you can access them through some means, right? And it is usually available for rent and for use, right? Now, your customer can access these servers from their own computers or other network devices, such as tablet or TV, right? So cloud servers can be started and shut down very quickly. And also they can be scaled out or scaled down as the demand increases or decreases, right? So you may rent a server and install your own software, or you may pay for access to software products that are available on the cloud. Now, you find out that these days, once you buy a piece of gadget, for instance, a mobile phone or a computer, in those days, we have CDs that are connected to those stuffs. And it is those CDs that you use to install all the software that you need. But now, once you buy your devices, you have to connect straight to the internet to connect to a remote server from where you download all the materials that you need, right? And also, you could also configure it to your taste by downloading things that you feel will make your life very comfortable in using that device. So we have moved from the age of, okay, you have CDs attached to a particular system or a particular device that CD used to install. Though some would also have some installed, not pre-installed as well, some kind of pointers to where you will download those materials that you need on your mobile phone or your system. So it's just like, okay, let me not jump. We call them images. So you just click on it, it downloads all that you need, and your system or your device is set up very quickly, right? So moving forward, the major characteristics of cloud software is majorly three, which has to do with scalability, elasticity, and resilience. what is scalability, what is elasticity, and what is resilience, and how are they important, and what is their importance as well. So scalability reflects the ability of your software to cope with increasing number of users, right? Now, as the load on your software increases, your software automatically adapts so that the system performance and response time is maintained, right? Now, elasticity is also related with scalability, but allows for scaling down as well as scaling up. That is, you can monitor the demands on your application and add or remove servers dynamically as the number of user changes. Then the concept of resilience is that you can design your software architecture to tolerate server failures. So you could have that you could have several redundant servers having some copies of what you have in your original server running concurrently. So you just be mirroring what is running on the main server on another one, so that if the main one fails, the redundant one can take up the work seamlessly. So you can make several copies of your software concurrently available. If one of these fails, the others continue to provide the service that is so required, right? Now, I think this calls to play with the banking industry, right? I think for a few, maybe I think for a few hours now, First Bank has not been, I've not been able to use my mobile app on First Bank. Now, what happened? Why can't they do their kind of requirement engineering in such a way that should the number of hits on their server increases, they can add more servers to cushion the effect? And it's not that we just, for instance, if you want to load up the app, it is done on your system, on your mobile phone, on your system. So the only thing that goes to their server is, okay, probably you select the account to be debited, then you fill up the number, the amount you want to do, or everything. So if you are transferring to other banks, that's when to now load the different banks that it has, right? So that is done, maybe it will the server once comes back, then you type in the account name, the account numbers, then it will go hit the server again. Okay, I think somebody's typing again. Yeah, who is this one? I didn't tell you to write your name. Yeah, so you have so what I'm saying in essence is that the requirement engineering for some of these bank apps should have been scaled up during this period of cash crunch. Some people will send money to individuals and you don't get it for 3-4 days. Some people are being detailed in the first station now because the funds they transfer has not hit the account of the creditor. So these are some of the things that we need to look at as developers or as managers of banks or managers of technology, that we need to put all these things together to make life easy for most of the users. You have your money in bank and you can't get it. Of course, we understand that there can be issues, just more than the software issues. You can have power issues, right? To get petrol and diesel now is a lot of stress. But nonetheless, you should at least make that you should just make things people just make it easy for people to get their funds. If I cannot get a physical cash, let me be able to transfer my money. So these are the characteristics of cloud software. So these are triangular characteristics. So We have looked at what cloud is. We have looked at the characteristics of cloud-based software. And what are the benefits of using the cloud for software development? The first one is costs, right? So you avoid the initial capital of procuring hardwares. Yes, if you're like, for instance, if you're a startup business or you're just trying to get things started, so you could start up your business with very little capital. Instead of investing in hardware and the cost of buying maybe servers, buying networking devices, looking for places to house those stuffs. You could just rent a pinch or a few servers and you're up and running. So it reduces costs for individuals starting their businesses and software development. Then the startup time for any cloud server is usually very minimal. So you don't have to wait for hardware to be delivered before you start work. Using the cloud, you can have servers up and running in a few minutes, right? So you could use servers, get them running as fast as possible. Unlike the hardware where you have to look for a network engineer who will help you set up your thing, it could even give you weeks before you do all the networking, set up the connections, and a host of other things, configuration and all that. So, and it may also be limited. The capacity of the server may also be limited. And for you to start scaling up, you have to buy several more hardware to achieve this. So it also helps you in the choice of server that you need. So if you find that the server you are renting are not powerful enough, so instead of having to buy another server or having to ship it back to the company that you bought it from, you can just upgrade. Now, upgrading, we have to do, okay, you look at, okay, which one is more powerful? So you do your research, okay, which one is better than what I'm using? Which one gives me more robustness, right? So it gives you a lot of choices. So you can add servers to short-term requirements, such as load testing. And once you are done with that, you dump it. So it's easy to scale up and scale down easily. So you could also have distributed development. One of the assumptions of agile process is that every member of a Scrum should be within the same location. However, we have seen that given the exigency of COVID and some other things, it has become very impossible for people to be in the same location to do any project. So we have a remote collaboration or remote coding, right? So in for cloud, it can help you if you have a distributed development team working from different locations. All the members have the same development environment and can seamlessly share all information. Excuse me. All right. So moving forward, let's look at some basic definition. Before the first one is the virtual cloud servers. So a virtual cloud server runs on an underlying physical computer and is made up of an operating system plus a set of software packages that provides the server's functionality requirements. So by definition, a virtual server is a standalone system that can run on any hardware in the cloud. So this run anywhere characteristic is possible because the virtual server has no external dependency. Now, I think when I was doing my opening remark, I think there's one person who has written something. Do we have a business opportunity with a bad design of banking system with respect to scalability? How open are they to third parts suggestion and contracts? the Japa syndrome has affected lots of banks. Lots of banks in this. Is this a factor? I don't think scalability has anything to do with manpower, but I could be wrong. Oh, okay. I think you want to ask if maybe manpower, a reduction in manpower is what is affecting uh, maybe the bad performance of businesses. Well, I think I've had to present on a different forum that it is not about manpower. It's not about manpower. It's about I think the whole issue started from their requirement engineering. For instance, Facebook also made the same mistake at the time. He felt the population that will be eating his app were just a few college boys. So the server he was using was just could just accommodate a few thousand people. But when it went to testing and he saw that, oh, this is no joke, he had to shut it down and maybe extend his design, right? So maybe let's assume that probably when he was deploying, there wasn't anything like cloud-based service. Of course, he had to invest in a lot on hardware servers, and that will cost him a lot of money. So I don't feel that, for instance, if an app had been developed, like sorry that I'm using First Bank or Zenith Bank, the app has been developed, you know that the number of customers you have, let's assume you have 40 million customers. It will be unwise for you to only provide the eating time for just 40 million customers. That's not wise. You could have people who have 2 accounts in that same Zenith Bank. And you could have people who have 3 or 4 accounts in that Zenith Bank. So by default, you should understand that you should have several servers that could accommodate maybe n complexity, maybe it may not be linear, it may not be quadratic or cubic complexity in the numbers of servers that you want to deploy. But you must have a baseline that, okay, we have 40 million people. So let's assume that our baseline is going to be 20 million hits. Then you can now scale up that instead of 120 million, let's look at the population of Nigeria times 2. So I think the problem really is from their requirement engineering from the beginning. And of course, you should also, of course, I went with a friend to on mass sites and all that. So where he was trying to explain some things to me of why some things are just there. So he said, okay, for instance, now one of the radio antenna, I'm not sure, maybe it's antenna or radio, is not working, it's not useful for now. But if there is a fault, there's a way that a fault detector will pick the fault and switch to another antenna so that at least there will still be a little coverage for those people up until maybe an error is generated and sent to the headquarters. Then they will send those people helping them to manage it to come down to come and repair the fault. He also mentioned that they have several power sources. You have solar and batteries, you have generators, and you have a NEPA. So if any of those power sources fail, the other one will take over using sensors. So I don't want to believe that it's manpower. It is, I think it's just a lack of proper investment. And if you look at those apps, they were developed by third parties, right? Probably the third parties didn't envisage maybe they didn't release sufficient data to the person who has helped them that, okay, this is the likely frequency of it at some time. For instance, during festivity, you should expect that the number of transactions you are going to handle is going to be a lot, right? So you should have prepared. enough. So you can't just deploy a few servers and few after everyone fails, then those ones can be in darkness for some time. And when somebody repairs it or they move to another location, they can get services. No, you don't treat businesses like that. So somebody said, I guess it's a trade-off, sir, because they do not have unlimited resources, hence they have to optimize to cut costs. You are correct, sir. However, we should have a minimal standard that at least availability. How would you shut down a LAN for, like, I've not been able to use my app since I woke up. Now imagine if I have to do urgent transfer, if it's an emergency, that means I won't be able to do that. So you cannot say a trade-off that can cost, like, at least there was a story I just had this morning that a woman died in labor because the husband's transfer didn't hit the doctor's account on time. So when the woman had died, the child had died, the next day, the money got to the doctor's account. So what are we going to do in this case? So what trade-off are we going to be looking at? So the thing is, do the best you can. For instance, now, there was a time Airtel just disappeared as usual. Now it came back. I was trying to use it, said I have a unstable connection. So I was not able to connect again. So I had to switch immediately to MTN to work. So if I just say, okay, let me just use only Airtel, that means this class will not hold. That's what it means. So we should be careful of the trade-offs that we talk about. Anything that is time critical, we should not even tolerate trade-offs. For instance, for those of us who are doing researches in medical areas, telemedicine, health, and e-services, the margin of error that we always report that you have 0.1, 0.00 something, we do not take it as face value. It's okay. Should this error occur, is there going to be fatality or otherwise? For instance, imagine that there is a stop in oxygen on somebody who is gasping for breath, and you say you have a margin of error. There are some things we cannot gamble with. Though in some things, for instance, I was reading a document earlier, maybe in the night, and I was reviewing a law report, and the law report was quite funny. And I think let me just summarize what he said. He said it is better for you to allow several criminals to escape than allowing one person who is innocent to suffer injustice. Now, he didn't stop there. He now said that this situation should also be put in context. For instance, you have terrorists, well armed, just brandishing weapons and running, just behaving madly. And you say, okay, you don't want to shoot them so that civilians don't die. The harm they will cause by the time they are charging through the city will be more. So it's better that you kill them, kill the innocent civilian there, than for you to allow them to go on rampage and kill more people than the innocent people with them. We presented this submission then when Boko Haram was starting. I said they should just carpet bomb the Sambisa forest, quote unquote. But there was no willpower to do it. Now, look at the number of people that have died as a result of tolerating their shenanigans. Look at the spinster groups that have developed from Boko Haram, and look at how well armed those people have become. Just because just less than maybe 12 or 10 years ago, we refused to do the right thing. The right thing, of course, appeared to be inhuman, but that would have been the best thing to do at that time. Now, Nigeria has spent I think from the last report, we have spent more than $1 billion. I think that's more. Maybe $1 trillion, I'm not too sure of the figure, but it's an humongous amount of money. And we have not achieved any results. So I don't think it's about the number of their staffs at JAPAD. And I also want to disagree respectfully that It's about unlimited resources. Do you know how much of your money they steal? Do you know how much those managers they share as a one profit like that, you call it? So why can't they invest that in infrastructures? So you see, it's about greed and lack of empathy. Yeah, sorry. So let's come back to class. Maybe when we are done, we have our answer. I think Anu Ogunleke is raising up. Maybe when we are done, please, we'll have you have your spots so that you can run through and finish the whole stuff. So the virtual machines running on a physical server hardware can be used to implement virtual servers too. So an hypervisor provides hardware emulation that simulates the operation of the underlying hardware. Now, if you use a virtual machine to implement virtual server, you have exactly the same hardware platform as a physical server. So you could have a virtual server and you could have it implemented on a virtual machine running an hypervisor, which helps you to have like an hardware replica, though it's still virtual, of the physical hardware that you would have used. Now, this is just a precursor to what this, of course, you know, we are dealing with software engineering. So this is just a precursor for you to know a few things. Now, some of these things, you should have learned it in networking, right? It's in networking and maybe database management, but we'll just pick a mention on them and move on. So this is implementing a server on a virtual machine. So you have different servers that you want to put. You have the server software, you have the guest OS, then you have the hypervisor, the host OS, and the server hardware. So now, as I was saying in the example of that young individual that came to meet you at a party to ask you for your order, right? You can decide to bring maybe pounded yam on one plate, drop it in front of you, go back, put a vegetable or any soup you want in another plate, go back, bring fish and fish, bring it to you, go back, bring meat, put it, go back, get one bottle of water, bring it, go back, bring one bottle of wine, bring it, go back. Now, that takes a lot of time, right? So there's a need for a concept of trade where everything that an individual has ordered for can be brought to that person at once and easily without having to wait endlessly before the person comes back to serve him the order. So you can just drop it and the person starts eating. So if you have if you are running a cloud-based system with many instances, now many instances could be rice, pounded yam, fish, meat, water, wine, plenty other things of applications or services. I'm just using that, so pardon my colloquialism. So this all uses the same operating system. You can use a simple virtualization technology called container. Now, using a container accelerates the process of deploying virtual servers on the cloud. Containers are usually megabytes in size, whereas virtual machines are gigabytes. Containers can be started and shut down in few seconds rather than the few minutes it requires to do that for a virtual machine. So what are containers? Containers are operating systems virtualization technology that allows independent servers to share a single system. They are particularly useful for providing isolated application services where each user sees their own version of an application. So once your food is put in a tray and the tray is dumped in front of you, it becomes your property, it becomes your own at that party. However, a number of things have been added to form what is in that tray. So that tray is a container that makes all those services to be customized to you. Moving forward, so this is an example of using containers. So you have user one having is you have user one having a personalized view. You have user two having a personalized view. So you have your meat, you have your rice, you have your bottle of water here. This one also has its own. Now this is the tray. You have water, and you have everything that you need like that. So you have a personalized view of what you really want. So that's what containers does actually. So containers were developed by Google around 2007, but containers became a mainstream technology around 2015. So an open source project called Docker provided a standard means of container management that is fast and easy to use. Just as you have databases and you have what is called the database management system, so there's a need to manage containers. And what is used to manage the containers is called the Docker. So Docker is a container management system that allows users to define the software to be included in a container as a Docker image. So you as a visitor to a party, you are well seated, well dressed. Probably you bought Asoebi or you didn't buy Asoebi. So you sit down there and you call the server, please, can I have this? Can I have this? Or you ask the server, please, what do you have? And it tells you, we have pounded yam, we have this, we have that. Now, some people are allergic to eating goat meat, right? Some people are allergic to eating red meat, right? So the Docker is like a management system that, okay, this is what we have. Can you tell us what you want us to put? Some people cannot even maybe take soup that has good smell. That's a very terrible smell inside it. Some people will not even want to take it. So you have to respect their opinion at that time because they have bought Asoebi and they have traveled far to come and sit down to honor you, right? So Docker is a container management system that allows users to define the software to be included. That means the food, the kind of drink. Some people take alcohol, some people don't. Some people take maybe small small quantity of water. Some people can take the biggest ever water. So what the Docker does is just to manage what should be included in the container itself. And what is included in the container, that's in the tray that is brought to you, is called, what do they call it in parties? When they serve people, I don't know. I'm not a caterer. So, but for containers, it's called a Docker image. So everything that is put in that container that is brought to you is called a Docker image. So it also includes a runtime system. Now, for those of you who did core computer science or computer engineering, you would have done something on memory management, right? Especially when it has to do with program management or compiler construction. Now, once you write your program, there's a contiguous block of memory that is given to you or given to you at runtime for you to execute your programs. So, and that program, the contiguous block of memory that is given to you is just empty and block. That's when I say block, that means it's just, it's not partitioned. So once you load at runtime, your code, your data, your stack, your heap is helps to segment that memory, contiguous memory given to you for the purpose of running the program that has been given to you. So it also includes a runtime that creates and manage containers using Docker, the Docker image. So the Docker is a management system. It defines what should be in the Docker image, and it also includes the runtime system that creates and manage containers using the image, the Docker image itself. So don't forget that we said Docker images are what is contained in the container. So moving forward, so the elements of the Docker container systems are, I don't know how to pronounce this correctly, but I think it's the Docker daemon or daemon. So this is a process that runs on a host server, and it is used to set up, to start, to stop, and to monitor containers, as well as building and managing local images, right? So what the Docker daemons is about, okay, you have to call the server, guy, please come. I need so and so and so. You'll be using your eyes to monitor the guy as he goes, because another person can just call him and tip him, and the guy will just forget you. So you continue to monitor, you stop sometimes. So to monitor the container, as well as building and managing the local images. So you will also be looking that guy is pounded yam I ordered for. Please don't go to where rice is, go to where the pounded yam is. But some of us don't like pounded yam, so we just say, guy, give us rice or whatever. So Docker client, the software is used by developer and system managers to define and control container. Docker files define runnable applications. Runnable applications are images as a series of setup command that specify the software to be included in a container. Now let's look at that again. Docker files define runnable application as a series of setup command. So what it does is that all the let me see. Let's look at the name, Docker image. All the Docker image that we have. So the Docker file defines runnable application, which is the Docker image, as a series of setup command. So it's like a pointer to what is on your plate. A pointer to what is on your, what's the name of that thing I called earlier? That container they put all the things you need and bring to you, tray. So it's like a pointer to each of the things in the tray that specify the software to be included in the container. So each container must be defined by an associated Docker file. So let's look at other definition. So we have seen what is a Docker image. So let's define it. So a Docker file is interpreted to create a Docker image. So I'm sure you have done linked lists, or let me see which one will be simpler for me to explain this concept. When you have pointers, simpler ones. Okay, let's use your house address, for instance, right? So you live in a particular house with a particular address. So for those of you who have done machine language, assembly language programming, or machine coding or something, you will know that we have different types of addressing mode. We have direct addressing mode, indirect, implied, implicit, and all that. So what the Docker file does, it points to an address that contains something. So a Docker file is interpreted to create the Docker image. So you have to get to that address first, unwrap the address, interpret the address to be able to get what is really in the that address. For instance, let's assume that you live in Bodilon, that's Tinubu's house. So if you want to look for you, we say go to number something, Bodilon Street, right? That's where you find him. So when we get there, we knock at the gate, we say we are looking for so, 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 and so. It gets opened and we say, oh, this is the person we are looking for. So Docker files are just like pointers to the content of the image, which is a set of directories with the specified software and data installed in the right places. So images are set up to be runnable Docker applications. So Docker Ops or Docker Hub. This is a registry of images that have been created. So when you have several content, maybe you have several trays and you have different kind of food on those stuff. So those different food or whatever that you have several of them. So they will now start bringing it table to table. Okay, so you ordered for this steak, you ordered for this day. But when all the servers are coming, those people that are carrying food to come and give you, once they are coming, they create what is called a hub. Right? So they bring the food, maybe 10 of them comes and they serve the 10 of you on that table. So whatever they drop on your table is a hub of an image created in a container. So this may be reused to set up containers or as a starting point for defining new images. So somebody will say, no, I don't want this. So they just maybe bring another tray, carry the food, and go and slam it on somebody's table who wants it. Or they can be used for defining new images. So instead of even removing it from that tray, you could just, okay, which of you wants this around this place? And they just give the person the whole content of your tray. So containers are executing images. An image is loaded into a container and the application defined by the image starts execution. So containers may be moved from server to server without modification and replicated across many servers, right? You may make changes to a Docker container, e.g. by modifying files. You could remove a Coke or what's the name of this stuff? Malt from people who have ulcer and they don't have to take any gassy stuff, right? And put water or something that will just like yogurt to help them with their stomach, right? So, but then you must commit these changes to create a new image and restart the container. Well, that may not be applicable to this example of catering services. So once you pull off the gas, this carbon containing drinks, and you bring maybe yogurt for them. So the image that you have created earlier has definitely changed. So what it says is that you have to update that, okay, we have taken malt and Coke, we have replaced it with yogurt for the benefit of the users. So this is a Docker container system. So Docker images. So of course, we have defined that already, but we want to look at them a bit deeper. So Docker images are directories that can be archived, shared, and run on different Docker hosts. Everything that is needed to run a software system, binary library, system tools, etc., is included in the directory. So a Docker image is a base layer, usually taken from the Docker registry with your own software and data added as a layer on top of this. The layer model means that updating Docker application is fast and efficient. Each update to the file system is a layer on top of the existing system. To change that application, all you have to do is to ship the change that you have made to its image, often just a small number of files, right? So like the concept of overwriting or writes and read operation in what's the name of this something access time or so. So what are the benefits of having a container? Of course, you know what a container is now. You know what images are, and you know what Dockers do. So benefits of using containers include they solve the problem of software dependency. You don't have to worry about the libraries and other software on the application server being different from those on your developmental server. So everything you need is put in. Instead of shipping your product as standalone software, you can ship a container that includes all the support software that your products may need or will need. They provide a mechanism for software portability across different clouds. So Docker containers can run on any system or cloud provider where the Docker daemon is available. They provide an efficient mechanism for implementing software services and so support the development of service-oriented architecture. They simplify the adoption of DevOps. This is an approach to software support where the same teams are responsible for both developing and supporting operational software. So, of course, when you come to cloud system, there are three categories that are generally known, right? And these are infrastructure as a service, platform as a service, and software as a service. But what we consider most important to us is software product as a service. So your software product runs on the cloud. Now, look at it. Your software product runs on the cloud and is accessed by users through a web browser, or also have a development on the cloud. So you would look at, of course, I think you'd have done something on, is it networking on cloud computing? So you'd have dealt more on some of this infrastructure as a service, platform as a service, and software as a service. But because we are dealing with software engineering and the processes involved in software development, we stick to our software as a service. So these are what we have just looked at. You look at software as a service, platform as a service, infrastructure as a service. So these are the management responsibilities for infrastructure as a service and platform as a service. We look at the duties attached to individuals, to software providers, to vendors, the difference there, and also probably the work that the user will also do. Let's look at software as a service in details. So software as a service, increasingly, software products are being delivered as a service rather than installed on the buyer's computer. Just as I explained earlier on, that instead of having your mobile phone pre-installed or your system pre-installed, what you have is just, I think, what's the name? I think we have Docker files, right? Pointing to what can be drawn from the cloud to your system. So you could just click on the Docker file that is already on your system, on your phone, and you start installing as much as you want. Right? Some of you may want to use your phone for watching movies. Some of you is just to receive calls, right? Some of you is for status symbol. Some of you are, I think, what do you call them? Vixen or what? Those of you that tell lies on the, sorry, there's somebody who just wrote something. Is this a default? Told you to write your name. Yeah, sorry for the pause. Yeah, so increasingly, software products are being delivered as a service rather than installed on the buyer's computer. If you deliver your software product as a service, you run the software on your servers, which you may rent from the cloud provider. Customers don't have to install softwares, and they access the remote system through a web browser or dedicated mobile app. The payment model for software as a service is usually a subscription model. And this subscription model can be in different formats. So user pay a monthly fee, some yearly, some weekly, for the use of the software rather than buy it outrightly, right? Now, this is a pictorial representation of software as a service. You have different customers. Then you have the service provider, which is you, and we have the cloud infrastructure, which is owned by the cloud provider. So you rent a portion, a server on the cloud infrastructure. You run or you deploy your software, or you also do a development. You could also have a development platform that you have your Scrum members log on to from different locations of the world. So what are the benefits of software as a service or product provider? The first thing is that you have good cash flow, right? So because people don't buy your product outrightly, you can have the products just in bits, little by little, here and there. So you have at least money coming into you most of the time. So the update management is quite easy. Then the continuous development is also easy. Then payment flexibility. So you can have several different payment options so that you can attract a wider range of customers. Small companies or individuals need not be discouraged by having to pay large upfront software costs. So you could also provide a dummy where somebody would just say free trial, try for maybe a month or 7 days. And after that, you could go on the subscription basis. I think I had to use one software like that on trial. Though after some time, when I saw that the advert was too much, I had to uninstall it. Then data collection. You can easily collect data on how the product is used, and so identify areas for improvements. You may also be able to collect customers' data that allow you to market other products of these to this customer. Well, I feel Mr. Olanite can speak to this on the use of cookies to get information from users. Now, there are a lot of dangers involved when they say we use cookie to collect these things. They may just sabotage you by taking maybe quasi information that are quite important to you, and someone will just do a guesswork. Before you know what is happening, they have thrown you out of your accounts and they have cleaned your account. Even First Bank that is not working safe, they would have done you great harm before they know what is happening. So these are the advantages and disadvantages of using service as a software as a service for most customers. So there are management issues for software as a service, right? And that concerns data storage. Now, there are a number of things that you need to consider when you want to deal with data storage. The first one is regulation. Second one, data transfer, data security, data exchange, and so on. Now, you have some countries that do not allow maybe data to just be stored without proper regulation. Now, still for those working in telemedicine, there's what we call HIPAA, right? You have to follow these stringent laws in such a way that you can't just get medical data of individuals just like that, as easy as we get it in Nigeria. You will fill a lot of forms. Now, after filling a lot of forms, you have to do anonymization. You have to do a lot of things just to make sure that the images are not exposed to unauthorized access. Not only that, the images should be useful after you have done the anonymization. Not only that, the images can be quite heavy. Then you have to implement compression on those images to reduce the size and the transmission time for countries where they do not have fast internet services, or areas that do not have good internet services. Then you do not use just ordinary compression like the lossy compression. You have to use the lossless compression using the lookup tables and the host of other things. So regulation is very important in data, especially when you have to store data. So such countries as EU countries have strict laws on the storage of personal information. This may be incompatible with the laws and regulation of the country where the software as a service provider is based. If that happens, providers cannot guarantee that their storage location conforms with the law of the customer's country. Businesses may be reluctant to use such products. So you have to consider, okay, where are you going to register, or where are you going to host your cloud stuff? For instance, there are a lot of trust deficit for Nigeria. So if you now say, okay, you want to put, you have to get classified data and warehouse it in Nigeria, the server is in Nigeria. People will think twice. They just know that before you know what's happening, somebody is calling you from a bank. And it's, well, I don't know if it's a bank. They'll just tell you your birth date. They will tell you the account name. They'll tell you the account, whatever. You say there's a transaction going on your whatever. They will tell you the phone you are using to collect alert and a host of other things. How did that information get out? These are issues that gives me a lot of headache. You know, you try to speak with bankers, but you know, they are quite protective of the brand and just say, no, it doesn't happen. It doesn't happen, and a number of people have called, not once, not twice, not 3 times, giving me correct information about myself. How did that happen? And you say it's not from your bank. So how did they know my account? Of course, we know those are fraudsters, but we have collaborators within. All right. So another issue is data transfer. So if software use involve a lot of data transfer, the software response time may be limited by the network speed. So for those who have to transfer data that are quite heavy and you don't have a good internet speed, this might be a problem. For individuals and smaller companies who can afford to pay for very high-speed network connection. Yeah, I was in a seminar recently and a candidate was presenting on edge processes or processing. So edge processing is just that you allow users to do more processing and the visit to the cloud will just be very minimal so that the issue of data or limited network speed is greatly reduced. And that's a concept that's been deployed in some of these bank apps. Data security. So companies dealing with sensitive information may be unwilling to hand over the control of their data to an external software provider. As we have seen from a number of high-profile cases, even large cloud providers have security breaches. You can assume that they always provide better security than the customer's owner server. Data exchange is another constraint, another concern. So if you need to exchange data between a cloud service and other services or local software application, this can be difficult unless the cloud service provides an API that is accessible for external use, right? For instance, medical images cannot just be opened by normal photo viewers. There are specialized API, specialized apps that we use to open some of those images. And that app is called the DICOM Viewer. And there's some other ones that could be used to open those images that you need. So if data exchange is to happen between somebody who just have this image viewer installed on his or her system, and you just say, well, let me send you one medical image, and you send it to the person, say, all I'm seeing is just one X in the center of the box. The person will not be able to view it, right? So those are the concerns that you need to look at when you are considering use of data. When you are dealing with data on SaaS. So what are the design issues you need to consider when you are looking at software as a service? Okay, thanks, maybe. Agbola Emmanuel Orunleke, who asks you to write your name? Okay. Well, I don't think I have to warn anybody again. If you do that again, I'll just yank you off, blacklist your name. All right. So you look at the local and remote processing. So a software product may be designed so that some features are executed locally in the user browser or mobile app, and some on the remote server. Local execution reduces network traffic and so increases users' response speed. This is useful when users have a slow network connection, right? So local processing increases the electrical power need to run the system. So would you rather trade off local processing for speed of eating the cloud services? So it's another consideration. Authentication. So if you set up your own authentication system, you have users who do not like to remember password, and I think I'm one of them. So many systems allows you to use your Google, Facebook, and LinkedIn credentials to log in. So it's already do you want to use your Facebook? Do you want to use your Google credentials? Do you want to use your LinkedIn and some other credentials are allowed these days. So for business products, you may need to set up a federated authentication system, which delegates authentication to the business where the users work. And also, you could also give them level of authority. That's okay, what you can access and what you cannot access. So information leakage. If you have multiple users from multiple organizations, a security risk is that information leak from one organization to the other. There are a number of different ways that this can happen. So you need to be very careful in designing your security system to avoid this. Another consideration is the multi-tenant and multi-instance system. Simply put, those who live in face me and face you, they are multi-tenants. And those who live in flats are multi-instance. But each of these issues also have, each of these considerations have their merits and demerits, right? So we're going to look at what is multi-instance and what is multi-tenant, and how can some of these things be mitigated. So in a multi-tenant system, all customers are served by a single instance of the system and a multi-tenant database. So maybe you have 6 rooms or 8 rooms. You just have one building with several rooms. You have 8 people living there. They share bedroom, they share toilet, they share cookhouse and everything. So in a multi-instance system, a separate copy of the system and the database is made available. So if you are living in a flat, you have your rooms, you have your maybe 3 toilets, you have bedrooms, you have your showers, you have your store, you have your library, you have your kitchen, and everything to yourself, right? So these are design issues that we look at as we have just discussed. So let's look at multi-tenant in, let's put it in perspective. So, well, this is Nigeria. So it appears they have taken life for some time and I've been running on my battery. So I want to put on the generator quickly, right? So I'm going to allow you guys to unmute yourself and have your discussion while I go to put on the generator with your kind permission. Do I have your permission to quickly run to put on the generator, please? Yeah, any response? Okay, I think somebody has responded. Oh, all right, thank you, thank you. So I'll be back in a few minutes, 3 minutes max. So Yeah, Mr. Lanite, can you raise up your hand so that I can put you as a moderator? So you'll be moderating while I go and put on the generator. Okay, I think I've seen you. Keep your hand raised now. Yeah, just repeat, please. So you are now the co-host, so you can moderate the time. Yeah, so I'm back. So Mr. Olanite, were there any fruitful discussions? Mr. Olanite, can unmute yourself now.
Sir, no, sir. No major discussion, sir.
Oh, okay. Thank you.
Yes, sir.
So let's continue then. All right. So let's look at the multi-tenant system and the multi-instance system. All right. So a multi-tenant database is partitioned so that customers, companies have their own space and can run and can store and access their own data. Now, there's a single database schema defined by the SaaS provider that is shared by all the system users. So you just have shared resources. So items in the database are tagged with a tenant identifier, right? Just like a Docker file. Just have something to identify, okay, room 1 belongs to this individual, room 2 belongs to this individual, room 3 belongs to this other individual. So the database access software uses this tenant identifier to provide logical isolation, which means that user seems to be working with their own database. So that's what it will present to them, as if, okay, you have your own room, everything is secured up until you have to wake up in the morning and you have to probably use the convenience, and you find the number of lines at the door waiting for everybody, go hurry up and all that. So this is what it looks like. You have different tenants with their keys. So tenants 516, tenants 632, and so on. So you have keys assigned to them, then the items that will be on their image and everything that they will need, and so forth. So what are the advantages of using the multi-tenant database? Of course, there is easy, good resource allocation, in as much as a whole lot, just one resource is used by so many people, right? So you feel that, well, you use these resources effectively. Then security, you have to be designed for security because data for all customers is held in the same database schema. They are therefore likely to have fewer security vulnerabilities than standard database products. Security management is simplified as there is only a single copy of the database software to be patched if a security vulnerability is discovered. Now, the question is, what about if we have a security breach, as it were? All right, so that's the question. So update management, it is easier to update a single instance of a software rather than multiple instances. Updates are delivered to customers at the same time so that the latest version of the software can be used by everybody at the same time. So what are the disadvantages? It's not flexible. So security, which I said earlier on. So as data for all customers is maintained in a single database, then there's a theoretical possibility that data will leak from one customer to the other. In fact, there are very few instances of this happening. More seriously, perhaps, is if there is a database security breach, then it affects all customers, which is a very serious problem. Then complexity, multi-tenant systems are usually more complex than multi-instance systems because of the need to manage many users. There is therefore an increased likelihood of bugs in the database software. Moving on. So what are the possible customization for software as a service? You could customize your authentication procedures. You could customize your branding. You could have your own set of business rules. You could also define your own database schema. Then your access control can also be customized, right? So these are things you could customize for yourself. So adding extended database. Now you have some extra columns to each database table and define a customer profile that maps the column's name that the customer wants to these extra columns. Now, why did this come? The issue is that customers may outlive the resources given to them. For instance, an individual who lives in Face Me and Face You may decide to get married. Apparently, one room may not be sufficient for him, given that he's going to be expectant in about a few months, right? So he needs to increase what will be his storage space. Then maybe, of course, he's going to be expecting the mama from the village to come and do umugo for them, and a host of other things. So as it stands, there's a need for him to increase the storage requirements that he will need. So in extending this requirement, we could do that by adding fields to extend the database or some other methods. So it is difficult to know how many extra columns you should include. So if you have too few, customer will find that they aren't enough for what they need to do. And also, if you cater for customer who needs a lot extra column, you will find out that most customers don't even use what you have assigned to them. So these sort of customers are likely to need different types of columns. That's different spaces. Now, for example, some customer may wish to have columns whose items are string type. Others may wish to have columns that are integers. So you can get around these by maintaining everything as string. However, this means that either you or the customers have to provide a conversion software to create item of the correct data type. For instance, if you allocate a room to somebody who is seeking for expansion, the person may want a very big room that he wants to use as a living room, where the other one may be used as the sleeping room. However, if you give him a room that doesn't link together, that constitutes a problem, right? But if you give him maybe a room that is just maybe just linking, then he may appreciate it. So if you give him he may not use the room that is not linking, and that is running to a loss on your part as the service provider, or what they call those people that rent houses. Forgetting their names. Agents, they call them agents. So that's one method. So you have, you see, there's somebody wrote something. Okay. I think this Fabi, you will be the one to pay for the sins of others. So Fabi Taiwo, I'm going to delete you permanently from this class. So you will not be able to attend the classes again, because I didn't tell you to write your matric number for any reason. So Fabi. All right. So I think if there are no corrective measures, some of you just continue to misbehave. So you have this extension in the columns so that at least anybody who needs it can just fill it up. So extending database using table. So instead of using columns, you could also extend database by using tables. So an alternative approach to database extensibility is to allow customers to add any number of additional fields and to define the name, type, and values of this field. The names and types of these values are held in a separate table accessed using a tenant identifier as a pointer. Unfortunately, using tables in this way adds complexity to the management of the database software. So extra table must be managed and information from them integrated into the database seamlessly and also correctly. So you have other tables, so you have a pointer from them pointing to where the tenant has extended to. So another consideration is database security. So information from all customers is stored in the same database in a multi-tenant system. So a software bug or an attack could lead to the data of some or all the customers being exposed to others. So key security issues are multi-level access control and encryption. So multi-level access control means that access to database must be controlled at both the organizational level and also at individual levels. So this is a so still on, just a few minutes, please. Yeah, I just saw a name that I need to delete from this class. Okay. All right. Yeah, I hope you can hear me now. So Information from all customers is stored in the same database in a multi-tenant system. So if there's a bug on attack, then there's a problem. So there are key issues that must be used. So we look at access control. So you limit the access that different people has, and also you could use the concept of encryption. Of course, I'm sure some of you would have done researches on types of encryption and history of encryption. Now, for you to be informed, encryption started way back from our great-great-great-grandfathers. They call it Aroku. For those of you who are Yorubas, they call it Aroku, or they could information hiding. Yeah, there are instances where they have to shave off the hair of an adult man. So a calligrapher will write everything that the king needs to send to another place. So it will be like a tattoo, so it dries up. Then after some time, the hair grows back and they'll send the man on his way. So when he gets to the other king, they will shave off his hair to reveal the content of what they have sent to him in form of information hiding. I think it's a steganography. So let's look at the multi-instance database. So here you are living in a flat. Yeah. Yes, can you see me, please? Hello. Okay. I hope you can see hear.
Yes, sir, we can hear you, sir.
Oh, all right. Thank you. So multi-instance systems are software as a service system where each customer has his own system that is adapted to its need. Now, to his or her need, let's not put it, including his own database and security control. So you have your gates, you have your paparazzi in your house, you have your fence built up, you have electric fence all over, you have your 3 or 5 bedroom, everything is just cool. So multi-instance cloud-based systems are conceptually simpler than multi-tenant system and avoid security concerns such as data leakage from one organization to another. So there are 2 types of multi-instance systems. We have the virtual machine-based multi-instance system. Okay, sorry, I was just reading the. So we have the virtual machine-based multi-instance systems and multi-instance systems where the software instance and database for each customer is run in its own virtual machine, right? All users from the same customer may access the shared system database. We have container-based. I'm sure you, when we looked at a virtual machine and container and all that, we went through that earlier. So container-based multi-instance system. These are multi-instance systems where each user has an isolated version of the software and database running in a set of containers. I'm sure you know what containers are now. So this approach is suited to products in which users mostly work independently with relatively little data sharing. Therefore, it is best used for software that serves individuals rather than businesses or business customers, or for business products that are not data intensive. So what are the advantages of using multi-instance database? One of the advantages is that it offers flexibility. You could have your security to yourself, then there's a scalability. So instances of the system can be scaled according to the need of the individual customer. For example, so customer may require more powerful servers than the other. Then resilience, of course, it continues to work even after faults has been detected. So what are the disadvantages? It is quite expensive. And for you to deploy updates to any of the instances, you have to deploy it to individuals, one after the other, which may take a lot of time. So this is the architectural decision for cloud software engineering. You have your database organization, scalability and resilience, software structures, and the cloud platform. The next consideration is what are the questions to ask when choosing the database organization to deploy? The first one is that you have to look at the kind of customers that you want to deal with. So Do customers require different database schema and database personalization? Do customers have security concerns about database sharing? If so, use a multi-instance database. Then transaction requirements. Is it critical that your product support ACID transaction where the data is guaranteed to be consistent at all times? If so, use a multi-tenant database or a virtual machine-based multi-instance database. Then let me just read through so you could look up on that. So database size and connectivity, database interoperability, system structure. I'm sure some of you know that interoperability is a very serious aspect of research in computing. And of course, it could serve as a form of a research topic for some people. And also, we want to look at a question of system structure. Are you using a service-oriented architecture for your system? Can customers' database be split into a set of individual service database? If so, use containerized multi-instance database. So let's look at scalability and resilience. The scalability of a system reflects the ability to adapt automatically to changes in load on that system, right? And this is what I was talking about with those bank apps. So probably this is a convenient place for us to have that discussion. So let me look at it. So the resilience of a system reflects its ability to continue to deliver critical services in the event of system failure or malicious system use. You achieve scalability in a system by making it possible to add new virtual servers, scaling out, or increase the power of a system system server scaling up in response to increasing load. So this is what banks should have done. They should have scaled out and scaled up to meet with the competing demands of the number of strikes that gets on their server. So in cloud-based systems, scaling out rather than scaling up is the normal approach, used. Your software has to be organized so that individual software components can be replicated and run in parallel. To achieve resilience, you need to be able to restart your software quickly after a hardware or software failure. So what is resilience? So resilience relies on redundancy. Of course, we have argued that resilience or redundancy is a bad thing in computing, right? Because it costs a lot of money. Now, once your system is critical, then the number of redundant nodes that you put should not be a consideration. Yeah, so sorry, please, there's another individual to be yanked off. Okay. Okay, so moving on. So you should use redundant virtual servers that are not hosted on the same physical computers and locate server in different locations, so that if there's a fire outage or there's a problem, you could quickly switch. Like we have banks being attacked. I think I don't know if that's true, but I watched some videos online showing some banks being burnt, some being vandalized, and a host of other things. Now, imagine if some servers are hidden in such maybe regional headquarters or zonal headquarters, and they have to shut down in a hurry. So, in a way, bank customer will be able to get access to his to whatever he needs to do. So ideally, this server should be located in different data centers. If a physical server fails or if there is a wider data center failure, then operations can be switched automatically to the software copies elsewhere. And Sensor is still part of this redundant node that will help in achieving resilience. So there's a good trade-off between resilience and redundancy, but the cost of redundancy cannot be overemphasized when you have a real-time application. So this is using a sensor. Once there's a problem, you switch automatically, you monitor the system. If you notice a failure, you switch quickly. So system structure. So an object-oriented approach to software engineering has been extensively used for the development of client-server systems built around a shared database. The system itself is logically a monolithic system with distributions across multiple servers running large software components. A traditional multi-tier client-server architecture is based on this distributed system model. The alternative to monolithic approach to software organization is a service-oriented approach, where the system is composed into fine, grain stateless services now, so that if you remove it from one place, it could move in this whole to another place without having to bother of dependency or something. So because it is stateless, each service is independent and can be replicated, distributed, and migrated from one server to the other, right? So this service-oriented approach is particularly suitable for cloud-based software with services deployed in containers. Now, I'm sure some of you have developed personal software, and you need to deliver it to a client. So everything this client needs will be automatically bundled together in a form of container. So what the person will just do is just to install. So if the person has a Visual Studios or a Java, whatever, it doesn't matter. It just installs it because everything that is needed by that software has been incorporated in that container. So cloud platform include general purpose cloud such as Amazon Web Services or lesser known platforms oriented around a specific application such as the SAP Cloud Platform. So there are also smaller national providers that provide more limited services, but who may be more willing to adapt their services to the need of different customers. There is no best platform. This can be arguable anyways. And you should choose a cloud provider based on your background and experiences or experience, the type of product that you are developing, and the expectation of your customer. So you need to consider both technical issues and business issues when choosing a cloud platform for your products. So these are the technical issues that you need to look at, business issues that you need to look at. The key points are stated here. I think I'm trying to meet up with time, and we have been able to look at what we have today. And I sincerely thank you for listening. Yeah, so the ground is open for discussions, right? For those of you who work in a bank and you want to throw in some defense for your bank and some other issues. So I think one Anu or something was raising up his hand earlier, but I was considering time. So this is the time for you to speak up. I think all of you can just raise up your hand and unmute yourself. Where is Mr. Anu? He has dropped off.
Oh, good afternoon, sir. I'm here, sir.
All right, sir. Can we have your position?
Actually, we've discussed what I wanted to talk about in the course of the lecture. So when we were talking about this bank, this issue with redundancy and feelings. So one of my colleagues talking about the fact that these organizations try to save costs. So that was what I was trying to just buttress, that basically most organizations, they are always mindful of their CapEx and OpEx. So, and most times they are always reactive instead of them to be proactive. So that's why we are where we are. The NCP and other regulatory bodies are doing what they can to ensure that this is minimized, but because of Nigerian factor, we still find ourselves where we are. For example, on February 14, MTN had a serious network glitch, which was not about the fact that they don't have redundancy in place. There was a multiple fiber cut all over the country. It's like somebody having multiple 5 to 6 links, and all of them went down at the same time. So what MTN suspect in that space is sabotage, and not. But generally.
So this one is going back to the table in the room.
Those disturbing place.
Please,
okay. Mr. Anu, you could continue your thoughts. We had some people who were talking.
So I'm just trying to say that it's basically the profit margin. That is what that is the major reason. We have other little reasons, just like sabotage. Some of them is maybe due to the fact that some of these companies were not proactive in their planning at the very beginning. So as the class went on, you spoke about some of the children's redundancy, that almost all of the companies. So and you spoke about the network, the telecoms mast. The example of the telecoms mast, it happens in my space. So it was very interesting to me. So like when the site goes down, another site picks it up. So because they know that in those areas they can still make their profits. That's why they will put more than 2-3 sites in that community. We have some locations where we have only one site, and once those site goes down, the total community will be out of service. So it still boils down to the fact that yes, we have some site locations that because of the forecast or the business case, it might not be justifiable to put more than one site there. So that's just my take. Thank you.
All right, thank you. Do you work with MTN?
Yes, sir.
Ah, okay. No wonder. I wanted to call somebody from MTN to defend the position. Now, I just hope that they didn't disturb you calling your girlfriend. So that's because there was a multiple failure. All right. Do we have any other opinion, please? Any other opinion, please? All right. In the absence of none, we thank you all for attending the class.
Hands are raised. Some people raise their hand.
Oh, sorry, I'm not seeing any of them. Okay. I think I've seen one Ade Bambo. Yes, Mr. Ade Bambo, Mr. Ade Bambo. You have
yes, sir. Yeah, my name is Tola. Just to buttress, to add more clarity in terms of the telecommunication. Now the mass is not actually to create more. The purpose of the mass is just to create more coverage. To add coverage and capacity. to areas being served. So that is the two main purpose of the mast. Then concerning what happened some months back concerning when there was a major failure, MTN had or let me say has a real disaster recovery system in place. It's a super bomb. So what happened was not even really MTN's fault. So I don't think it can be classified as a sabotage from someone. No, it was a major problem beyond the control of MTN. So although MTN still took the responsibility because they are the one providing services to their customer, yes, which is the normal thing to do.
Yeah, I can see some people writing their names. I didn't ask you to write your names. I'm going to blacklist you now. All right. So sorry for interrupting, sir.
Okay. So then regarding what's it called? Scalability.
Yes.
MTN has a very good plan in place because I had the opportunity of working with the network group in that regard. So when you talk of scalability among the other competitors, MTN has the best anyway. So yes, I'm talking
soon give
because
you friendly fire now.
No, they can talk. I've worked with MTN in terms of expansion and also with others like Zain. So I know what I'm talking about. So
sorry, Mr. Dibamba, the network group. Which unit?
All right, thank you, sir. Mr. D. Fabi.
We will talk about that later, Ross. All right, thank you, sir.
All right, so Mr. D. Fabi Olani.
Yeah, all right, sir. So I just wanted to make a point about when we talk about greed and being in business, to make money, because at the end of the day, no business is a charity. So it's a thin line actually thinking about it as greed versus we're in business and we're not a charity organization. Because at the end of the day, I have investors, I have loans and all of that, and I have competition who is able to do, I have competition who is also able to do this business a bit more efficiently and effectively. And when you look at all of those factors, at the end of the day, these are areas where they optimize. So it's important for us to just understand that fact that it's not just greed that will make that happen, because I've been a part of an organization that invested capacity for, say, 20 million users. And then for whatever reason, they lost ground in an area of competition. The competition kind of came very hard on them. And their users felt about, say, 10 million or so. Now, all that became a profit. That company never recovered anyway, because it meant they overinvested. So there are factors and reasons why you have to be cautious when you are investing in capacity, versus thinking about it as greed. I agree with you. There has to be, a way for us to ensure that.
I think that it was not well planned. That is what I would say, because the politicians have this money at home, they stack it, and you want to really attack them. Normally, that 500, 1,000 is what the bank will issue to everybody. Why can't you just give us an abundance of the 200, the 100?
Sorry, Sani, I think.
Even before you redesign this naira.
Sorry, Sulaiman. I think we are talking about two different things.
Oh, sorry.
We are talking about two different things. So
sorry, please. Sorry.
Yeah. So I'm just trying to make that point. We need to just understand that fact. It's a business. There are shareholders, there are investors, and they're not going to listen to you to say, you bring to me a bill of $20 million when someone is able to do something with $10 million and there has not been a problem. I'm not going to listen to you. So that's essentially, a part of the point I'm trying to make.
Thank you, sir, Mr. Difabi. All right. Okay, there are also other issues that is affecting us. One of it is petrol. One of it is Naira. And those of you who work in bank, I hope you have been keeping safe. I hope you have not been lynched. I heard that one was killed yesterday. Well, my condolences to the banking family. It's a difficult time, right? But I don't know. So can somebody educate us why we're having scarcity and how that can be managed using softwares? Any banker with us? Mr. Nasiru.
Yeah, hello, sir.
Yes, please.
Okay, so actually, I think